Hello and welcome to Maths class, proudly brought to you by School Media and edufirst.ng. I bet that you're having a good time with our online lessons. Yeah. So what are we looking at today? We're taking a look at calculus part 4, and specifically integration. In our last 3 classes, we talked about differentiation. This time around, we're taking a dive into integration. I'm Uncle Ed. So by the end of this class, you should be able to determine the equation of a line or curve given its gradient. You should be able to use the inverse of differentiation to find the general solutions of simple differential equations, and also apply the rule of integration to integrate algebraic expressions. These are quite simple, but first of all, here's a quick review of what we need to understand. Suppose the equation of a gradient function is simply dy dx. When you differentiate an equation, that is the gradient function. So dy dx is 2x in this case. This means that y is x squared, which is a curve when you plot it on your graph. But for accuracy, we attach a c to y equals x squared to make the equation true for a general case, that is, a family of curves parallel to y equals x squared. Hence, the y dx equals 2x is the gradient function of y equals x squared plus c. So if the y dx is 4, then y equals 4x plus c. And if the y dx equals 3x squared, then y equals x cubed plus c. So what is integration? We can say integration is the process of finding the expression of y in terms of x when given the gradient function. It is the reverse of differentiation. You're given a gradient function, that is the y dx. The process of finding the equation, the original equation, is actually integration. So x squared plus c is called the integral of 2x with respect to x, and c is called the arbitrary constant or constant of integration. The equations dy dx equals half and dy dx equals 2x are called differential equations, and y equals half x plus c and y equals x squared plus c are the general solutions. So take note of that. Integration calculus can be used for finding areas, arc lengths, surface areas, and volumes, even in coordinate geometry. So there are quite a number of applications for integration. What is the integration rule? It says, if dy dx equals x squared, then y equals, please take note of this very seriously, y equals x raised to the power of n plus 1 divided by n plus 1 plus c. That is the integration rule. That is how you differentiate an algebraic term. So if y equals dy dx, if dy dx rather equals kx squared, then y equals kx raised to the power of n plus 1 divided by n plus 1 plus c. So what we do is we add 1 to the power of x and divide by that new power gotten. It's that simple, where k is a constant. This rule holds for when n equals 0, n equals positive, and n is negative. So it does not apply when n is minus 1. If dy dx equals x cubed, then y equals x raised to the power of 3 plus 1 divided by 3 plus 1 plus c. So if we solve that, we're going to have x equals x raised to the power of 4 over 4 plus c. So what if we have dy dx to be 3x squared? Yeah, you can do that on your own. And what you get is y equals x cubed plus c. So that is the integration rule. Here are 2 more examples to buttress our points. Integrate the expression x cubed minus 4x squared minus 6x plus 3. So if the y dx is this equation that is given, then y equals, integrating each term of that equation, we have x raised to the power of 4 over 4 minus 4 times x cubed over 3 minus 6 times x squared over 2 plus 3x plus c. So that is applying the integration rule. So when we simplify that, we would have x squared over 4 minus 4x cubed over 3 minus 3x squared plus 3x plus c. That is the answer. Example 2 says integrate the expression x cubed over 2 plus x squared over 3 plus x over 4 plus 1 over 5. So this involves fractions. It doesn't change anything. The rule still applies. So the y dx is the equation as given. So we simply apply the integration rule for each of the terms. And when we simplify to the end, we're going to have y to be x raised to the power of 4 over 8 plus x cubed over 9 plus x squared over 8 plus x over 5 plus c. Please ensure you solve this on your own for better understanding. Let's take a look at the integral notation. The symbol used for integration is summation. Yes, that symbol is called the summation symbol. So if the x equals f of x, then a equals the integral of f of x dx. So the a dx was actually treated as a fraction. So you simply multiply both sides to have the a equals f of x dx. So you integrate the right hand side to have a. If, for example, if f of x is 3x squared plus 4, then the a dx is 3x squared plus 4, and a equals 3x squared plus 4, the integral of 3x squared plus 4. So when we integrate that using the integration rule, we have x squared plus 4x cubed plus 4x plus c. The symbols is actually an elongated s that stands for summation. Integrals of the form 3x squared plus 4 dx are called indefinite integrals because they do not have a limit. In solving definite integrals, we use the method called integrating between limits. This method is explained using the area bounded by a curve. So let's have a peep into what integrating between limits mean. If a curve y equals 3x squared minus 4x plus 2 is bounded by the x-axis and the lines x equals 1 and x equals 5 as shown, first we carry out integration, then we substitute the upper limit and lower limit in turn, and the second result is subtracted from the first result as illustrated thus. So we have this graph of a curve bounded by the red lines. Now, how do we get the area of the blue shaded region of that curve? We do that by integrating between limits. So dy dx equals 3x squared minus 4x plus 2. Then a is, that is the area of the shaded region, the integral from 1 to 5 of 3x squared minus 4x plus 2 bracket close dx. So you can see the limit as given in the question. So what we do is we integrate the equation first of all, and what we get was x cubed minus 2x squared plus 2x. Then what we simply do is substitute 5, the value of 5, into the equation, minus substitute 1 into the equation. What we get is 84 square units. So that is integrating between limits. Here is your home exercise. Please ensure to send in your answers. We'll be waiting to hear from you. Thank you and have a good day.